Example 3, write the vector equation of a plane containing the point 1, 4, 1 and this line. Okay, so from the line, we get a point, or a second point I should say. So we get the point 3, 7, and 0. And we also get one direction vector. We get the direction vector -2, 8, and 5. So we have 2 points now and one direction vector. We need 2 direction vectors and a point. So for the second direction vector, we're going to get it by subtracting the 2 points. Okay, so I'll do this point minus the other. So 3 minus 1 would be 2, 7 minus 4 would be a 3, and 0 minus 1 would be -1. Okay, double check to make sure that the 2 direction vectors are not multiples of each other, which they are not. And so now we're going to use 2 direction vectors and one of the points. Doesn't matter which one, because both of them are contained within the plane. So the equation is going to be r equals, I'll choose the point 3, 7, 0, plus t times our first direction vector, plus s times our second one. And where t and s are elements of the real numbers. So once again, it didn't matter which order you subtracted the points in. Both of those vectors would be perfectly fine to use as a direction vector. And it didn't matter which of the 2 points you used, because once again, you could use any point that lies on the plane. So example 4 is our next one, and it asks us to write the parametric equation of a plane containing both of these lines. So once again, we have 2 points because there's a point on each of the lines. And we do have 2 direction vectors. So our first direction vector is 1, -3, 2. And our second direction vector is -3, 9, -6. And now you want to see if they're multiples of each other. And if you look, that direction vector 2 is actually -3 times direction vector 1. So if we multiply direction vector 1 by -3, we get -3, we get 9, and we get -6. So we can't use both of them. So you can choose one of them to use, doesn't matter which one. And now we only have one direction vector, so we need to find a second one. And we can find the second one using the 2 points. So our second direction vector, I'm going to call it M3 because M2 is already used. I'm going to subtract my 2 points. So 2 minus 0, 5 minus 6, 7 minus -1. And I get a direction vector of 2, -1, 8. So there I have my second direction vector that I need. And last but not least, you need one of the points. Okay? Doesn't matter which point you use. I'll just choose the first one. And now I can create my parametric equations. So we're going to need an x equation, a y equation, and a z equation. Starting with the point is 2, 5, 7. Okay, and then our first direction vector would be 1t minus 3t plus 2t. And our second direction vector would be plus 2s minus s plus 8s, where s and t are elements of the reals. Okay, so there are our parametric equations. So you'll notice that you could have gotten different parametric equations. They would have represented the exact same plane, depending on the point that you used and the order that you subtracted the points to get your second direction vector. Also depending on which of the two direction vectors originally that you chose to exclude. But even though you would have gotten a different answer, it would have represented the exact same plane, the same way that multiple equations for lines can represent the exact same line. So if you have any questions at all, please contact your teacher. Otherwise, here is the suggested homework for today.